So just to quickly jump into it, what I really want to talk about is leveraging digital twins for private networks in oil and gas. So before jumping into it, I just want to give a quick introduction about IBwave and essentially where I'm coming from. First of all, I'd like to thank everyone for having me here. Personally, I am an avid believer in digital twin technology. I believe it's essential, and I believe in uh, technology going forward, how relevant it is, especially when it comes to wireless networks and the way wireless networks are revolving today. And this is kind of an introduction to where our software actually fits in. So what IBwave really focuses on is deploying, surveying, and modeling in-building wireless or wireline networks. So essentially everything you need for your data communication inside a building. And what we focus on is really having an agnostic solution, so a technology agnostic solution. So regardless of what technology you're deploying, whether it's 5G, LTE, Wi-Fi, IoT, a public safety network, a LoRaWAN network, we offer a technology agnostic solution to really help you design and plan your network, just so that it meets your excellent grades of services that you're looking for. So essentially, just a little bit about our products. It's a software-based company that really supports different users at different parts of the life cycle. So we have a mobile application that's really focused on doing multi-technology surveys. So really starting to understand the environment that you're going to start deploying your network in, understanding the wireless interference, understanding the architecture of the venue, and we have a 3D in-building network design software. So leveraging the information that you pulled in your survey, the architecture, the interference, allowing you to properly design and deploy your network. So if it's a 5G network, an LTE network, a Wi-Fi network, just being able to plan accordingly to what you're seeing in real life out there at the venue. So we also extend outside the venue as well, especially in the oil and gas industry. You need both your indoor coverage, but also understanding the outdoor interactions as well. So we have a solution that really helps encompass not only your in-building network, but also your outdoor network. So really being able to plan accordingly and seamlessly. And this is something that's very important in networks today because it's not only about your coverage inside, but also how your coverage is supported in parking areas or in campus areas or environments that is also considered outside, but also looking at the interaction. Let's say you have a device that's going from inside a building to outside a building, or even a user having an excellent experience as he's walking from inside the venue and outside the venue. In many cases, we see that inside the venue you have good coverage, but as soon as you walk outside, you drop coverage. So ensuring you have seamless connectivity throughout your entire campus. And finally, what I would say is we also have a training and certification program. So it's not only about the technologies you're designing and deploying for, but also how to use the tool to deploy and design for those technologies as well. So we've been around for 20 plus years. We have thousands of customers worldwide. And something we really focus on is partnering with equipment manufacturers. So looking at Ericsson's and CommScope's and Corning equipment, making sure that they're properly modeled so that they could be simulated in a digital twin environment inside your building as well. So really down to the manufacturer specifications of how it's supposed to be performing, what those antenna patterns are like to ensure that you have the appropriate coverage and such. So up to date, there's over 500,000 buildings deployed using IBwave design worldwide, and there's 5,000 certified professionals who know how to use the software and know how to address the technology that they're designing for today. So that was just a quick introduction. Like I mentioned before, I'm an avid believer in digital twins, and I'm even more a believer in how this is going to impact the evolution of network planning in building and in campus environments and in outdoor technology as well. So I really don't want to preach to the choir and talk about what a digital twin is or what BIM is, but I really want to set the context that this is where we're coming from. So really taking a venue as a digital twin environment. So you're treating the venue as your digital twin in this specific case. The point I really want to focus on is when you look at BIM technology, it supports various different industries that we're talking about today. So whether it's architectures or structural designs or HVACs or electricians. But one thing that is not as common is BIM being used for connectivity. And in my perspective, this is essential for the way technologies are going, the way wireless technology is going, but also looking at how these buildings are becoming smarter and smarter. So you look at architects, you look at HVAC technicians, you look at electricians, and you start looking at their equipment as well, and they're starting to have smart elements associated to it. So there's a smart HVAC, there's smart lighting, there's smart electricity. And what's essential for these smart technologies is ensuring that they have the fuel, which I consider connectivity as the fourth utility, ensuring that these smart equipments are fed with the connectivity they need to be able to perform. So if you look at traditional legacy networks, it's always been about ensuring that there's connectivity to an end user. But the definition of end user is actually changing now, because the end user could be a machine. It could be a very data capacity hungry machine, like a high definition camera that's transferring data in real time. So this is why I'm an avid believer that connectivity should be part of this ecosystem. And this is what we're suggesting in this presentation, but also suggesting the implications it can have when it is treated in this entire ecosystem, and especially how this could touch in the oil and gas industry. So my next slide is really talking about how digital twins could enable a data advantage. So when we look at private networks and we look at having a wireless network, the advantages are clear. So these are just some of the benefits you could have in oil and gas, and I'll go through some of them, like thinking about sensor-based optimization for energy consumption, remote asset monitoring, making sure everything is working properly, reduce downtime through predictive maintenance, location tracking and communication in hazardous areas. A very big one is autonomous vehicles. So I usually like to talk about autonomous vehicles because coming from the wireless world, we're often asked, where is private networks heading? We always hear about this big boom in private networks, but we're not seeing it come as fast as we're anticipating. But what I really am seeing is in private networks today, where we are seeing movement and where we are seeing traction is where there is what I like to call kind of a no-brainer use case. And we're seeing a lot of these no-brainer use cases, especially in Industry 4.0, oil and gas settings, mining as an example, because everything that I'm mentioning here are potentially no-brainer use cases. Thinking about employee safety, that's a no-brainer use case. Having AGVs, like I was talking about before, we've seen in the mining industry that some of our clients have achieved over 200% in efficiency by automating their vehicles. Cost savings, coming back to consumption, making sure you're not over consuming, making sure that you're using electricity at the right time, making sure everything you're consuming at the right time and the right stage. Power saving as well, and automation as well. So automation is key for every type of efficiency that you're looking for, whether it's in power, whether it's for employee efficiency and such. So we look at all these different use cases, and if I jump back to some of them, thinking about wearable sensors for gas detection. So again, employee safety, smart energy management for your lighting and your HVAC. Again, that goes down to efficiency. Reduce site visits and reduce truck rolls through remote monitoring. So especially when you look at the oil and gas industry, there is so much no-brainer use cases. But the challenge when it comes to private networks is understanding what is the fuel to essentially enable all these use cases. Because if we start looking at the wireless technologies that we have on the right, we have LTE, we have 4G, we have LoRaWAN, we have Zigbee, wireless HART, IoT, Bluetooth, Wi-Fi. So there's a various set of different technologies, and it comes down to understanding what's the most efficient technology for your use case. And sometimes when we're looking at deploying a private network, we might not be able to justify our ROI because we're looking at maybe the wrong technology, or maybe looking at using the most expensive, the highest end technology for your entire facility. But one of the advantages of digital twins is you don't have to look at a holistic approach or one technology that is going to enable everything. You don't have to look at deploying the best-in-class 5G network to support everything that I'm looking for. When in reality, you could start treating your facility as essentially a a facility with a roadmap. And in that roadmap, you could start addressing what is the right technology for the use case that you're actually implementing. Because if you look at some of the benefits here, like wearable sensors for gas detection, that's going to have a different wireless technology requirement than autonomous vehicles, as an example. So depending on your roadmap, the right technology may not be you may use the wrong technology for your use case. So essentially what I'm suggesting is kind of taking a holistic approach and not trying to solve every one of these use cases at the same time, but start building towards a technology use case. And this is really where the advantage comes with a digital twin. So again, I don't want to try and justify my ROI by deploying 5G everywhere, but perhaps I could start looking at deploying 5G for my autonomous vehicles, because that is going to drive my ROI. And perhaps I could also look at deploying Wi-Fi technology for areas in a conference room where people are going to gather and would like to have proper data communication in that conference room. So again, it allows you to take a very holistic approach. And this is kind of what my next slide suggests, is having a digital twin allows you to take more of a technology roadmap approach where I could say, today in the outdoor lots, I'm going to potentially deploy 5G because 5G is much more efficient than 100 different access points to essentially offer the same benefit that I'm looking for. And maybe in 6 months' time, I might start looking at adding Wi-Fi in the conference room, and then I could start layering on IoT as well. So instead of looking at one solution to solve all your problems, you could take much more of a roadmap approach and start aligning it with what you're trying to achieve, your use cases that you're trying to achieve. And it becomes much more of a cost-efficient solution, and it becomes much more beneficial for you to support a timeline and start stacking use cases that you're trying to deploy to meet your ROI. And I could tell you a lot of times that what we're seeing in the private network space is that it's becoming very hard to justify an ROI because they're trying to justify it by looking at a singular technology to solve all the problems. Now, especially in the oil and gas industry, there is so many problems that you can solve, and there's so many efficiency and there's so many different efficiencies that you could find by addressing use cases, but not necessarily in a one holistic timeline. So again, it's about leveraging the digital twin, using it to your data advantage, and understanding how these different technologies can support one another. So what's also important when you're starting to deploy your network and having a digital twin is you can start understanding how these different technologies are going to interact with each other. So if I have Wi-Fi, is that going to start interfering with another network that I have, or IoT? So this is kind of the purpose of leveraging a digital twin, to understand and start layering on technologies as you're trying to justify your ROI for specific use cases, and understanding how it's interacting with the different technologies you have in your building. And obviously a key requirement for that is to continuously keep your building, your BIM model, your design up to date with the technologies that are there and with the technologies that are running. So if I have Wi-Fi today, I want to know what's going to be the implications of if I add maybe 5G or LTE in the outdoor environment. So again, this is really kind of the crux of our software. It's really about planning your in-building network to support the use cases. So I want to plan my network in accordance to having an AGV run across this building or run across this campus and whatnot. Or I want to deploy a Wi-Fi network so everyone in my venue could have proper communication inside that venue. Or again, like I was mentioning before, I want to make sure that my outdoor areas have full coverage as well. So really, what I'm suggesting here is really starting to look at connectivity as really that fourth utility, and understanding that when it comes to connectivity, there's various different technologies. It's not about comparing one technology for another. It's about really evaluating what's the right technology for the use case you're trying to accommodate for. So when it comes to the digital transformation, usually what I suggest is sometimes there's kind of a misconception that there's a lot of upfront investment to get started, when I'm really suggesting it's more about leveraging technology to your advantage. And it's really about starting with a data mind frame. So when it comes to wireless in-building technology, what I would really suggest is start understanding what data is really relevant for you. And as you start your project, having that data mindset in the back of your mind. So everything that you're capturing, everything that you're replicating, everything that you're modeling ends up becoming a valuable asset if it needs to be a valuable asset. So when you start looking at maybe where do I get started, maybe it might be in a survey where you're trying to understand the architectural requirements of the venue, or maybe you're trying to understand the wireless signals that are floating around or interfering inside your venue. But there's several different tools to help you understand what's going on in that venue. So leveraging this technology, but also keep in mind that whatever you're capturing is going to be an asset for you going forward, because at the end of the day, you're not only looking at deploying a network, you're also looking at creating a digital replica. Now, in the wireless world, what's important in the digital replica is understanding what kind of signals you're seeing inside the venue, but also the architecture of the venue as well. Because if you have a lot of plaster everywhere versus a lot of metal everywhere, your equipment, your antennas are going to perform very differently in different types of these environments. So as you're starting your digital footprint, as you're doing your survey, in the wireless world, those are key sets of information. So you have different technologies to help you capture that information digitally. So what kind of interference you're seeing inside the venue, but also what kind of architecture you're seeing in the venue as well. So again, different attributes and characteristics of different wall materials, or if you have heavy machinery, how that's going to impact your wireless signal as well. So again, it's also about leveraging digital twin technology to support what you're doing in the survey as well. So it's not about spending all this upfront work to create a digital environment. It's about leveraging this digital environment to help you guide your surveys as well. So when you look at wireless technologies, more and more you're going to see that they're taking up a lot of real estate inside your telecom closet. So a lot of spaces on walls. So you're going to have to start accommodating more and more for these wireless technologies, for servers, for equipments, for base stations and whatnot. So again, when you're doing a guided survey approach, what you can do is you can start understanding right then and there as you're doing your survey, if I have room to accommodate for different equipment. So start strategizing of how I'm going to place my equipment, how I'm going to maximize the real estate in one of my telecommunication closets as well. So again, architecture, equipment, how you're going to leverage that equipment and how you're going to place that equipment as well, to really start guiding your design. But most importantly is, also very important is understanding the wireless behavior inside your facility, because especially in the oil and gas, you're going to have a lot of different communication and interference frequency, a lot of different frequencies inside your venue that could potentially interfere with your communication systems. So understanding what's going on inside that venue. So again, there's handheld tools. IBwave as well has handheld tools to help you to scan that environment and understand what that environment looks like. So I have a little graph here that kind of shows what the environment looks like even before you deploy a wireless network. So this is very important because when you start designing your network, you need to overcome that interference. You need to adjust your power levels. You need to really understand where you're going to place your equipment. And equipment placement, I would say, is one of the most essential parts of your planning process. So where am I going to place my APs? Where I'm going to place my small cells to ensure that at the end of the day, I'm going to have the adequate levels of coverage everywhere inside the building, inside my priority zones, and especially supporting the use cases that are necessary. So whether that's outside the venue or whether that's inside the venue, whether that's in your warehouse or whether that's in your conference room, just really ensuring that you have those proper levels of service, and you're also accommodating for the architecture you're seeing inside the venue, but also the interference you're seeing inside the venue as well. So just another graphic here on the right. This is essentially as you're planning the software, you're seeing all these colors, but what these colors really represent is the level of signal you're achieving with a simulated scenario of placing an antenna in a specific location. So if I have one antenna, am I going to get green everywhere? So green means good. Or am I going to have areas in red that could be essential that I need to make sure that I overcome? So especially in a digital twin environment, what this allows you to do is to start simulating, okay, if I place an antenna here, is this the right location? Do I need to adjust the tilts? Do I need to adjust where the antennas are facing just to make sure that I don't have those red areas? Or how can I overcome these red areas to properly simulate the levels of coverage inside my facility? And essentially, that's really that last point I had is around automation. So how do you automate your network planning to make sure that you don't have any of those reds anywhere, and those reds are not impacting the use cases that you're trying to develop? So what I would also suggest is also a key aspect of leveraging digital twins in a wireless network is data interoperability. So especially in the oil and gas industry, like I was mentioning before, you need to know your outdoor coverage, but you also need to know your in-building coverage. So GIS is a very important tool to be able to visualize what's going on the outdoor network, going on the outside versus what's going on in the inside. So it kind of gives you a holistic view. And I want you to think of like an AGV use case that could be going inside a building and then traversing outside to the campus. So imagine how detrimental it will be if there's an area that is not properly covered. So your AGV might stop at a certain point in your facility and really impact the use case of having autonomous vehicles and the efficiency of having autonomous vehicles. So again, it's very crucial to ensure you have proper connectivity throughout your entire facility, so outdoor and indoor. But one of the advantages of having data interoperability is that it allows you to have that holistic view. So where I have transmitters or equipment on the indoor, where I have them outdoor, and really how they're going to be interacting with each other, making sure that they're positioned properly, making sure that at the end of the day, you don't have red spots anywhere, outdoor or indoor as well. Again, what's also very crucial is leveraging your connectivity and your assets in your connectivity in asset management, for asset management as well. So imagine a scenario where an AP goes down. Imagine that impact, how that could trickle down to your efficiency. So an AP went down, so now my AGV isn't working properly. So again, just being able to really understand how your assets are performing, your wireless assets are performing, just having a view of that and ensuring that it's properly working at full times, or even having predictive maintenance if something goes down, just to be aware ahead of time that something is going down or something is not functioning properly. Because at the end of the day, if your communication goes down, think about all the use cases that can be impacted with your communication going down. So again, having this holistic view and being able to manage all your assets. So again, like I mentioned, it's about having all your assets in kind of a technology agnostic mindset. So I want to see my assets. I want to see my 5G assets. I want to see my Bluetooth assets. I want to see my Wi-Fi assets. And I want to make sure that they're running and performing the way they should be, because I have mission critical systems that are going to be relying on them. I have efficiency that's going to be relying on them at the end of the day. So really leveraging your building as a digital twin for understanding how your wireless network is continuously performing and ensuring that it's continuously performing as well. So I just want to leave some time for questions, but again, if we were to summarize some of the key points that are mentioning, so all those use cases and process optimization at the end of the day are essential, because at the end of the day, having a digital twin, and maybe a point before that, if you look at the legacy process of wireless technology planning, it has been very much one survey and one design for one technology. So I'm doing a one design and one survey for Wi-Fi. 5 years later, I'm doing another survey and another design for LTE. A few years later, I'm doing another design and another survey for 5G. And it's not a holistic approach. So, and at the same time, there's so many truck rolls involved in these surveys. There's so many different designs. instead of leveraging your building as a digital asset, where instead of doing singular designs and singular surveys, you could take a layered approach. So I have Wi-Fi already. What happens now if I layer on 4G? What happens now if I layer on 5G? So there's a tremendous amount of efficiency in reducing truck rolls, but it gives you a more holistic process, because at the end of the day, you want to know how these different technologies are going to be interacting with the technologies you already have in place. So the legacy approach doesn't make sense because you're not really understanding how your 4G and your Wi-Fi are going to interact together, or how they're going to support one another, or how they're going to interfere with one another. So again, that's one of the key processes of having a digital framework. And having that digital framework allows you to create a roadmap and make your ROIs more ingestible, to be honest, because your ROI isn't going to be about solving every single problem. It's about really creating a digital roadmap of the problems you want to solve with the most cost efficient technologies you want to solve at the moment as well. So it becomes
Uh,
much more easier to start justifying your ROIs. Yeah.
thank you,
And my
thank
last point before I close off is just about that data interoperability and understanding how your network is performing at all times, at all costs. So I'll stop right there.
thank you so much, Mr. Chaudhary. This was a lovely presentation as well as enlightening presentation for us. At the right hand side of your screen, you'll be able to see few Q&As from our delegates. Please answer those as we are left with only 2.5 minutes as of now. Please proceed ahead.
Yes, so let me jump into that and see if I could start seeing the questions. So I have some questions. So I'll pick and choose some questions. Some questions require much more context, so I'll skip those for now. Um, so one of the questions we have are with regards to support regulatory compliance. So um, especially so digital twins are essential for regulatory compliance as well, and it's more about supporting regulatory compliances, because when you look at standards as public safety, there's really requirements for having adequate coverage in the venue, but also having adequate coverage in specific areas of that venue where emergency response is needed. So having a digital twin could really support justifying compliancy when it comes to public safety networks. So ensuring that this is my design, I'm going to prove that it's performing the way it should, and I'm showing the design steps that I'm taking to ensure that I have proper coverage inside my building, but also proper coverage in areas like stairwells and areas as elevator shafts that need proper communication for first responders as well and such. So it becomes very essential. At the end of the day, it's going to be essential that you prove out that you do have that proper communication systems. But the advantage of digital twins is it makes it much easier to justify your system in place, justify that it's performing the way it should, and justify that at the end of the day, it's meeting the adequate levels of requirements for public safety. I have a lot of questions about case studies. So I would suggest that I have my email in this presentation. So we could share some successful case studies in different verticals. So we have a lot of successful case studies in Industry 4.0, in mining specifically, some in oil and gas, but we could share those with you. Just send me an email and I'll share those with you. And unfortunately, I have very little time, so I'll just try and take one more. So my take on digital twins help make oil and gas workplace safer, especially in dangerous areas. So I think this is one of those no-brainer use cases that I was talking about. So when you have a digital twin, but also you have the use case to support safety, so worker safety. So in the wireless world, we're seeing so much uptake in sensors or employee sensors, or being able to track these employees or where they are, and having a digital twin, but also having the wireless network that supports the safety of these employees and making sure that these sensors are working properly is essential. It's kind of one of those no-brainer use cases that I was talking about. So I think I'm running out of time. I'd love to answer these questions, so I'll answer them individually after this presentation. So thank you so much for your time and for your attendance.
Thank you, Mr. Chaudhary. Thank you very much for sharing this enlightenment presentation. We genuinely appreciate the valuable insights you have provided. And you can also join our new session, that is the already session has started. So you can join them, you can listen them. And thank you very much. Let's have a connect again for further queries. Thank you, everyone.
Absolutely. Thank you, everyone.
Bye bye.